This is a revision of the summary for Lesson 1, Number Puzzles, from Unit 4, Linear Equations and Linear Systems. This puzzle, twice a number plus 4 is 18, so what is the number, can be solved in several ways. You can reason through the problem, you can make a diagram of the problem, or you can write an equation of the problem. Each way is a method to get to this solution. In this case, the number is 7. So the answer, or x, is 7, and down here, x is 7. I'm going to go through each of these in more detail, but first, think about inverse relationships regardless of the method that you use to solve the problem. So if you see twice a number in a problem, eventually you will have to use the multiplicative inverse of 2 in this case, which is 1/2. So 2 times its multiplicative inverse, also called the reciprocal, is equal to 1. And 1 is the identity property for multiplication. So any number times 1 is equal to that number. So you multiply by the multiplicative inverse, you in essence remove that 2. Anytime you see plus a number, in this case plus a positive 4, think about the additive inverse in this case. So if you have a positive 4, you're going to add a negative 4, that equals 0. So any number plus its additive inverse equals 0, and 0 is the identity property of addition. So any number plus 0 equals that number. So when you add the additive inverse, you in effect get rid of that number. In this case, get rid of the positive 4. So these are the inverse relationships to look for: multiplicative inverse and additive inverse. So if I write this answer in symbols, so a number is 1/2 4 less than 18. So 18 plus a negative 4 is the same as 18 minus 4. So x is equal to 1/2 4 less than 18. And so you have to think of that 18 minus 4, 4 less than 18 inside parentheses, and that operation has to be done first. That partial answer is 14, and 1/2 of 14 is 7. So look for those inverse relationships as we work through each of these ways or methods to solve the puzzle. So reasoning through to solve the puzzle, if the last step is to add 4 to get to 18, to get back to twice a number means that that twice a number is 4 less than 18. So the idea is to use the additive inverse. If you're adding 4, then to get rid of that 4, you're going to add a negative 4, which is the same as 4 less than 18, or 18 minus 4. And that equals 14. And that 14 is twice the number. So to get back to the number, you're going to use the multiplicative inverse of 2, which is 1/2. And so 1/2 of twice that number is the number. So 1/2 of 14 equals 7. Another way to solve this problem is using a diagram. So this is a diagram of the problem right here, but I didn't like this diagram because it's not to scale, so I redrew it. If you look at this 4 right here, this is drawn as being larger than 7. Well, that's just not correct. And 2x is 14, and 14 is much more than half of 18. It's around half of 18 in this drawing, but 14 is more than 2/3 of 18. 2/3 of 18 is 12, so 12 would be about right here, and 14 should go up to about right here somewhere. Once you've solved the problem, go back and check the diagram. If it's not correct, draw it to scale, make some notes, so you can study those notes and diagram. So here is the diagram drawn correctly. It's useful to use a grid. So these are 18 units. So 5, 10, 15, 16, 17, and 18 out to here. So the problem says twice a number plus 4 is 18. So twice a number is 4 less than 18. So here's the 18, here's 4 less than 18, and then twice that number to get to the number is half. So here's 1/2 and 2/2, and so that number is equal to 7. So x equals 7. Twice that number is 14. So it gets you out to 14, plus 4 is 18. So once again, working backwards, 4 less than 18 is 14, and half of 14 is 7. So here's the problem in words and symbols. And it's important to put this of 4 less than 18 inside parentheses, because if it was written this way, you'd have to calculate 1/2 of 4 first, which equals 2. And so this would read as 2 less than 18 or 16. Well, that's not correct. So you have to put this inside parentheses. So 1/2 of 4 less than 18. So here it is in symbols and numbers. 1/2 of 4 less than 18, which by the way is the same as 18 plus -4. You're going to use the multiplicative inverse. So if you see twice a number or 2 times a number, to go backwards, to move back to that number, you're going to have to take 1/2 of it. You're going to have to multiply it by the multiplicative inverse, which is 1/2. So 1/2 of 4 less than 18. And if you see plus 4, you're going to have to use the additive inverse to remove those 4 units. So plus a positive 4, the additive inverse is a -4, so plus a -4. So 18 plus a -4 gets you back to 14. So 18 plus a -4 gets you to this 14, and 1/2 of 14 is 7. So 18 plus a -4, by the way, is the same as 18 minus 4. So you're taking off those 4 units, or you're adding a -4 to those 4 units. So once again, the multiplicative inverse and the additive inverse. Another method is to write and solve an equation. So here is twice a number plus 4 equals 18. So how do you get back to that number? You have to solve the equation. To solve this equation, you're going to use the additive inverse to get rid of this 4, and you're going to use the multiplicative inverse to get rid of this 2. So the additive inverse of a positive 4 is a -4. An additive inverse means that a number plus its additive inverse equals 0. So this becomes 0, and that's the identity property of addition. So 2x plus 0 is 2x. So now you have 2x is equal to 14. So you're adding the additive inverse to get rid of that 4, and then you're going to multiply by the multiplicative inverse of 2, which is 1/2, to get rid of this 2. A number times its multiplicative inverse equals 1, and 1 is the identity property of multiplication. Any number times 1 equals that number. So you get rid of this 2 by multiplying by its multiplicative inverse, 1/2, and you're left with x equals 7. I like using a combination of diagrams or drawings and equations to solve these problems. The authors are going to move students away from using diagrams because they argue that those methods get harder and harder. Equations get to be more and more helpful. So the power of writing and solving equations to answer increasingly more complex mathematical problems. I think of it in the opposite way. I think that the diagrams become more and more helpful as the equations get more complex. They help you see the mathematics as you're working through the equation. There is no better example of this than Albert Einstein, who used thought experiments to figure out the hugely complex theories on which he was working. In addition, Ken Robinson gave a wonderful TED Talk on how schools kill creativity. And basically he's saying that we have lost that visual and active element in our curriculum that has killed creativity. So we have to bring that back. We have to continue to connect a visual aspect, in this case of mathematics, to the symbol manipulation. Here is a link to Einstein's thought experiments and a link to Ken Robinson's TED Talk. And so the links are really about conceptualizing physics and fully integrating the arts into a K-12 education. I believe that where we really lose the creativity in mathematics for a middle school and high school student, and even an elementary student, is when we move away from the drawings. It is important to understand the symbol manipulations in algebra, of course it is, but those manipulations can always be represented in drawings. As much as possible, try to construct those drawings. I know I'm getting out there on this one, but I think it's important. Mathematics is the language of our universe, even beyond the confines of our planet. Diagrams provide a visual element to that language. In a search on visualizing mathematics, I came across an interview of John Zweck, who is a professor at University of Texas. And he calls what he's teaching his Calculus 3 students geometric imagination, helping students learn to form and to manipulate geometric objects in their minds. Creative mathematics at any level relies on forming pictures in your head. Here is a QR code that is a link to the interview with John Zweck that describes geometric imagination, and a QR code to some of the models that he's posted from his Calculus 3 class. So very high level mathematics in which he's pushing to visualize the math.